Hello, everyone. This is Miss Peterson, and I am going to be going through 12.3 and 12.4 notes with you today. Yes, we're doing both sections together, so just be aware it's going to be a little bit longer of a lesson compared to what you have done in the past, but I tried to pare it down as much as I could to make it as simple as possible. So the first part are learning targets. I love looking at my students' notes that have them listed at the top of their note page. I had some requests for these on the slides that were missing them, but it will help focus your note-taking skills so you know what you should be getting out of the section. So feel free to pause the video and write these down if you are one of those types of people. But basically, we're going to be solidifying an element's symbol, atomic mass, and atomic number, knowing what they are and why they're there. We're going to talk about some relationships on the periodic table, so groups and periods and what those mean. And then we're going to talk about repeating patterns of chemical and physical properties that we can see on the periodic table and why it was put in the order the way it was. So this first part should be a little recap for you, but you can always use the periodic table that we have in the General Resources Material tab on Google Classroom. The periodic tables are linked there. You can always just pull one up on another tab on your internet browser so you have something to reference, because we do need to utilize the periodic table in Chapter 12. So the atomic number, reminder that this is going to tell us how many protons there are in an atom, right? And then the atomic mass tells us protons plus neutrons. So if we were to round this up, we know that there are 3 protons over here. And if we subtract 3 into 7, we know that there would be 4 neutrons in our element lithium, right? So that's a little recap. Sometimes these numbers are on opposite sides, but just remember the atomic number is always the smaller number, and atomic mass is going to be something with a decimal place attached to it. Anyway, the periodic table was organized by a guy named Dmitry Mendeleev. He was able to put them in order by, obviously, atomic number, but there are many repeating patterns of physical and chemical properties on the periodic table that we'll be able to identify. We like to say it's going to be your best friend for this chapter because you do have to reference it a lot when you're figuring out protons and neutrons and electrons and things like that. The first 2 terms that we see are periods versus groups. So on a periodic table, periods are going to be the horizontal rows as you go across the periodic table. So if you see my little pointer down here, as I go across this entire row, this would also be known as a period. And on a periodic table, there will be numbers that are listed on the side here. So if I were to ask you, what is the period number for this element? You could say that it's number 4 because that's listed on the periodic table. So all of these rows are called periods. Then the vertical columns are called groups, and we can see that some of these groups have fancy names to them: alkali metals, halogens, noble gases. So we'll talk about those in a little bit. We do want to know why they're called that and what characteristics go along with them. But again, you can see here's our dark blue group in a vertical column. Here's a light blue group in a vertical column. So groups are columns. Elements that are in the same group or the same column are going to have similar properties to each other. So the very first group, that dark blue group I was referencing, that are called the alkali metals, one of their traits that they talk about here is that they can bond with oxygen on a 2-to-1 ratio. So potassium, sodium, lithium, they're all in the same group, and they all do a 2-to-1 ratio compound. Just as an example of a repeating chemical property. One of the main features was Mendeleev was able to put all the metals on one side of the periodic table for the most part, and the nonmetals on the other side of the periodic table. So all these yellow elements, and note that our book is a little dated. We know that these actually have names now, and they were found and identified. So there's a few that are not the same, but these are all metals down here, or the majority of what we see on the periodic table is going to be a metal element, right? And then these are our nonmetals, these green ones over here on the right side. And hydrogen over here also is a nonmetal, right? Hydrogen gas. It just has some characteristics that line up with the rest of these bad boys in that first group. Reminder of some general characteristics. So if I were to ask, what are some characteristics of a metal, you would be able to say that they are shiny and silvery, right? Because metals are just like that. But you would also be able to say something about like they are good conductors of heat and electricity, like we talked about in chapter 9. And then nonmetals are going to be gases or liquids. And they will be good insulators or poor conductors of heat and electricity. Okay, so those are some basic characteristics that we got. The next thing is atomic masses are listed on our periodic table. Most of our periodic tables show them with a number and a decimal place at the end. And as Pressler already talked about, we know that has to deal with their different isotopes for an element. How do we get these mass numbers? An atomic mass unit is what we use to describe the base unit of the atomic mass on the periodic table. So instead of using something like grams, we use something known as an AMU, or an atomic mass unit, which is approximately the size of one proton, which makes it a lot easier to deal with. If we were working in grams, we'd have the insane decimal places that we were working with, and that's really annoying. So now we just call those AMUs. All right. I'm going to talk about the groups on the periodic table. So there's 4 that I'll go through. You want to know their characteristics, and then listing a couple examples of them is helpful too. So the first group on the very far left side of the periodic table, that first group is known as the alkali metals. They are soft and silvery because they're metals, right? Or shiny and silvery, sorry. But their feature is that they are soft. So you can literally cut these metals with a spoon and scoop them out if you wanted to. And the other feature is that they are very highly reactive. So they react with oxygen and they react with water like instantaneously. So these ones are stored safely in oils and dark rooms, things like that, to keep them from exploding, basically. If you see any videos, YouTube videos of people chucking elements into the water and then you see big explosions, it's probably an alkali metal that they threw into the water, something like sodium or potassium. All right, so that's the first group. The next group is the alkaline earth metal group, and they are called earth metals because they are readily found in Earth's crust. They have similar properties to the first group, which is why you can see the word alkali, like the first group, in there, because they are also pretty reactive. They're shiny and silvery, just like any metal would be, but they are found in Earth's crust, and they easily bond with oxygen, so we can see they make those compounds on a 1-to-1 ratio down there. Now, we're going to jump all the way to the far right side of our periodic table. The second to last group over there is called the halogens. Halogens are going to be nonmetals, so gases or liquids. And they are also very reactive, super reactive, but toxic in their pure form. So we see these examples: fluorine, chlorine, bromine, and you might, you probably are more aware of their compound forms, like fluoride from the doctor and chloride from sodium chloride, like table salt or chloride compounds that are used in pools, right? So when they are in their compound form, they're no longer toxic. But if they aren't monitored properly, it can be a little dangerous. So that's why fluoride from the dentist has to be controlled. If the chloride that goes in the pool is a little off, you'll notice that you might get red eyes or have really itchy skin when you get out of the pool, and that just means they have to make some adjustments. Otherwise, it's going to be a little dangerous. Okay. And then our last group, all the way over on the far side of the periodic table, are the noble gases. So that vertical column over there, these are also known as inert, which just means they do not react. And the reason that they don't react or naturally bond with other atoms is because their outermost electron energy level is going to be completely filled with electrons, which Pressler already talked about in 12.2. But the outermost energy level is completely filled, so they do not react, which makes them so noble and special. So those are our main groups that you should know. The rest, or the big chunk that's kind of in the center of the periodic table, those are called transition metals. Means, they're shiny, silvery like any other metal would be. They're good conductors of heat and electricity like any other metal. And then the other properties that they might have are kind of random, but they fit the same sort of bill. So they are all called the transition metals. Even the two that go down towards the bottom, those two rows, they're also known as transition metals. They can be labeled as rare earth metals, or they might be called lanthanides or actinides. And that just is labeled after the first element in their period or row. One last feature is the bold stair-step group. So on every periodic table, you're going to notice like this black line. They're not all color-coded, but you'll at least see this black line off towards the nonmetals over there. And these are called the metalloids. These are going to have properties of both metals and nonmetals. So they're there separating out our nonmetals from our metals. One other repeating pattern that we might see is how many electrons can be found on each energy level. So the very first period or row, their electrons fit in the ground level or the low energy level that can only hold 2 electrons, right? So that'll be that first energy level. The next period, their electrons will fill into the second energy level, so on and so forth for the third period and fourth. So that's another repeating pattern that we can see on the periodic table. This last image is just a color-coded version of the periodic table. And I like it a lot because it has them all labeled on there. You can find one of these on the internet like I referenced before. Talks about the periods over here and the numbers that go with it. Groups can be labeled by the number at the top here. And then you can see other features in here. So talking about the general configuration of the tile, where the atomic number is versus the mass number, what are solids, liquids, and gases. So that's 12.4 notes for you, or sorry, 12.3 notes for you. I'm going to pause and save this thing, and I will go through 12.4 with you in a little bit.
We're here.